Sketching curves, cubics. You need to be able to sketch equations of the form y equals ax cubed plus bx squared plus cx plus d, where a, b, c and d are constants, or a plus a, x plus a, x plus b, x plus c. Both of those are ways of writing a cubic equation. In order to do this, we have to find the places where the graph crosses the axis and then do an appropriate sketch, very similar to how we did it with a quadratic in the previous video. Cubics take one of the following shapes. They either look like that or they look like that, depending on whether we got x cubed. X cubed is what I would call an upward squiggle, or minus x cubed, which is a downward scribble. So in the same way with quadratics we have U-shaped and N-shapes, with x cubes we have upwards and downwards cubics. So if we're going to sketch the graph of the function y equals x minus 2, x minus 1, x plus 1, then firstly we have to find the solutions. If y is equal to 0, that means that one of those brackets must be equal to 0. The product of three things means that one of the things must be 0 for the actual product to be 0. This is the same idea as solving a quadratic. So x is either 2, 1 or minus 1. Those are the three solutions, or the three roots of the cubic. So we know it's going to cut the x-axis at minus 1, 0, 1, 0 and at 2, 0. And if x is equal to 0, that will let us find out where it cuts the y-axis. So if we set x equal to 0, then we have 0 minus 2 times 0 minus 1 times 0 plus 1, which is 2. Minus 2 times minus 1 times plus 1. So it cuts the y-axis at the point 0, 2. And that is all of the information that we need to know in order to sketch the cubic. Because we now know that because it's going to be a positive x cubed, because x times x times x is positive x cubed, it's going to be an upwardly squiggle that crosses at minus 1, 0, then crosses again at 1, 0, and crosses at 0, 2, and also crosses the y-axis at 0, 2. So once we know that, we can then do an upwardly squiggle and we can see it's going to look that sort of shape, like that one there, with the suitable curved bottoms. Sketch the graph of the function y equals x minus 2, 1 minus x, 1 plus x. Again, if y is equal to 0, that means that one of the brackets must be 0 for the product to be 0. So we can find that the solutions, or the roots, are 2, 1 and minus 1. So it cuts at minus 1, 0, 1, 0 and 2, 0. If x is equal to 0, we can find where it cuts the y-axis. So it cuts the y-axis at 0, minus 2. In this case, when we times it out and we do x times x times x, it's going to be minus x cubed. So because it's going to be minus x cubed, once we've plotted the points, we know it's going to be a downward squiggle. So we have a downward squiggle then for the minus x cubed. And if we substitute in x equals 3, we can see it carries on, so it is a decreasing function after that point. Here's another example, y equals x minus 1 squared times x plus 1. Same idea, if y is 0, means that one of those must be 0. This time we get 1 and minus 1. So we got that squared bracket. What that squared bracket is telling us is that there's a repeated root. So in the same way that when you have quadratic and a repeated root, is where it touches the axis, the same way that happens here. At the 1, 0 thing, there's a repeated root there, so it touches the axis there and crosses at minus 1. And we can find where it cuts the y-axis in the same way when x is 0, so it cuts the y-axis at 0, 1. So when we plot the points, we've got minus 1, 0, 0 to 1, the repeated root, and 1 0, so it looks like that. So if we see and something minus something squared in a quadratic, that means it's a repeated root at that point. X cubed minus 2x squared minus 3x. In this sort of case we have to factorise. We look at factorising cubics much more in C2. In this case there's a common factor though. We can take the x out as a common factor, so we're left with x squared minus 2x minus 3. Once we've taken that out, then we can factorise the quadratic, so factorise it fully, x minus 3, x plus 1. We then find our three solutions, so we know where it cuts the x-axis. We can then substitute x as 0 in to find out where it cuts the y-axis. Once we know those things, and we can say it's an x cubed graph, so it's an upward squiggle, then we can draw the graph, plot the points, upward squiggle that goes through 0, 0. It looks just like that. We also need to be able to sketch and interpret cubics that are variations of x cubed. Now this is something we'll look at in a lot more detail in C2, but we can plot the graphs in the same way we have already seen. And if you can understand it, this is a bit of a shortcut. So let's say we want to sketch x cubed. X cubed looks like that. It's a graph we should know the shape of. Minus x cubed, well, if that's the graph of x cubed, then minus x cubed will be a reflection in the x-axis. So we can quite quickly draw a graph of reflection in the x-axis to draw minus x cubed. And now we can see that the points are reflected. There's a line of symmetry that is the x-axis. How about x plus 1 cubed? You should remember from GCSE translations of graphs that x plus 1 cubed translates the graph 1 to the left, or minus 1. It's what returns the bracket back to 0. So minus 1 will return the bracket back to 0, so it translates it 1 to the left. When a is added to the cubic inside the bracket, it's a horizontal shift of minus a. And you see the graph is moved 1 along. We should also work out any intercepts when we translate the graph. So for our new graph, when we substitute x as 0 into it, we can see it cuts the y-axis at the point 0, 1. When sketching graphs, you should always label all of the different places where it cuts the axis. Three minus x cubed is minus x minus 3 cubed. The minus sign means it's reflected in the x-axis, and the minus 3 means there's a horizontal shift of 3 to the right. So we translate the graph 3 to the right, and then we reflect it in the x-axis. Again, we should work out where it cuts the axis. So it cuts the x-axis at 3, and if x is equal to 0, it cuts the y-axis at 27. And we label the graph suitably with those values.